Hello geometry students. Today is Wednesday, April 29th, and I hope you're having a good day. It's beautiful out again, and today's my mother's birthday. I know many of you have heard stories about her, and she is 93. So I'm going to be taking her to the doctor, which is very necessary, but I also do get to at least see her. So that's wonderful. I hope you have a wonderful day too. So let's get started. I'm going to say a prayer for our lesson. Father in heaven, I just thank you so much that you're faithful and good. I pray for all of my students that they would understand everything very well, master the material, do great on their chapter 12 test, and that you would strengthen me and help me to be the very best teacher I can be. And we just thank you, Lord, that even if we do math for you, it will last forever. In Jesus' name, amen. Okay, well, I hope you enjoyed the short little video with the popcorn project to consider different volumes and what that means and to have a little fun. And so let's get started on our lesson for geometry. And I already drew the pictures, so that's a little bit easier for me. So you can pause it when you need to draw a picture, but I'm trying to shorten my lesson. That'll make getting the video to you much faster. Okay, so in general, the volume formula for prism and cylinders is the area of the base times the height. Now this B is the area of the base. I believe we've talked about this. That's different than a base length. Okay, so whatever shape is the base, that is the 2D shape formula that you're going to use. So whether you have a rectangle or a triangle or a pentagon or a circle, the area of the base is the big B. Okay, so now we're going to do this one, so you can go ahead and pause the video if you want to draw the picture, which you should in your notes, and we're going to find the volume of this 3D trapezoidal prism. So it's going to be the area of the base times the height. So the area of the base is a trapezoid. You can see that especially on the bottom, right here. We color that in. See, that is a trapezoid. Okay, so that's B1 plus B2 times H. So let's figure that out first. These actually are quite easy because once you find the area of the base, you just multiply by the height. Nothing complicated about that. All right, so I have 1/2, and then B1 would be this length here. Now down here I'm told it's 6, and because both bases of a prism have to be the same, this is also going to be 6 up here. So that would be 6 plus 14. Now the height of the base is not 5, it's going to be 3. It's inside my base figure here. This 5 is the height of the overall prism, okay? And remember, the height is always perpendicular to the base, so finding this little symbol here, or being told it's a square or rectangle, is critical for finding that height. So that's 3. So when I work that out, I get 6 plus 14 is 20. Half of 20 is 10 times 3 is 30. So to find my volume, it's going to be the area of the base times the height, which is going to be 30 times the height of the figure, which then is 150. And these are centimeters. Now, with volume, that's different than surface area. Volume has 3 dimensions, length, width, and height. So this is going to be cubed. I'm multiplying 3 dimensions there. Okay, let's do B. So you can go ahead and draw that picture of a cylinder like this. And my volume is going to be the base area times the height. And the base area is pi r squared. So I get 9 squared, which is 81 pi Okay. And then my volume then will be 81 pi times the height of the figure, which is 6. So that is 486 pi. And if I work that out, I get 1,586.81 feet cubed. Okay, very important with the 3 there. On your test, you're going to have problems that are surface area and problems that are volume. For surface area, you would need feet squared or centimeters squared or meters squared, inches squared. For volume, whatever your unit is, it has to be cubed. All right. Now, what if we had an alarm clock, which I don't know if anybody is using at this point. You might have one in your bedroom, but we're told that the value of x, find the value of x, and I didn't draw that in, so x is all 3 dimensions, and we're told that the volume is 90. So this time, we're working backwards. So my volume is also base area times height. Well, I'm told it's a cube, so that means that all of my dimensions are the same, right? So you have a square on the bottom, and then the height going up is the same as each of the sides. So I'm going to figure this out. The base area is going to be, well, let's see, we put 90 in, and the base area is going to be x times x, and the height is also x, so that becomes x cubed. All right, and now you use your calculator. Be careful on this. You want to go on your special calculator, not your cell phone. And there it should be a button that looks like this. Okay, so it takes the cube root of x. So you're asking what number multiplied by itself 3 times is 90. Okay, so I put 90 in and I hit the cube root button and I get that x is approximately 4.48. Now just to review this, because you haven't looked at algebra for a while, what that means is that 4.48 times itself 3 times should be 90. X cubed, x, and let's see, let me try that. 4.48 times 4.48 times 4.48, and I get 89.9, which would round up to 90. So that's what that means. Okay, let's do number 3. This is quite a picture. Find the volume of the puzzle piece. I'm sure you've seen puzzle pieces like this before. You can go ahead and pause the video and draw the picture, and then we'll figure it out. Okay, so why don't we go ahead and figure this out. Now this is volume, so I want all the parts of it. It's a 3D shape. So I'm going to change colors so that I can easily talk about this. So I'm going to split it up into 3 parts. I can split it into 3 prisms here. Do you see this one? And this comes down back here. Okay, so there's that one. So I've got this length times this length. So really, the volume is going to be this block plus this one in the middle, and then the tall, thin one at the end. This is my plan here. Okay, you don't have to draw it all like this, but you get the idea, right? I've got this one here I'm going to start with. So the volume of this one is going to be, let's see, well, this is 2 here, and let's see, we know some things here. This whole thing, there's always clues. You've got to look for the clues. I don't know what this is. Well, this actually is 2 because this is 2 here. Okay, how am I going to find this here? So I know this is 2, and I know this is 2. I need to know this up here. Well, I can look for that length in other parts of the picture. So this is going to be the same as this, which will be the same as this, the same as this, and the same as this, because all the way along has the same width, right? This one here has the same as what's up here, and I can see that all the way along. So I know this is a 2 also. So I've got 2 for a height, 2 for the width, and 2 for the length. So I'm going to have 2 times 2, whoops, times 2, which is 8. Okay, now I'm going to have, that's this whole section here. So now I'm going to look at this part of my 3D shape here, the part that's in the middle. And I know this is 2, okay? So, hang on one second. If you look at the picture in the book, they have a grid. And I couldn't really draw that. And what that shows is that there are 2 boxes, 2 units here, so that this would be 1. All right. And I have this distance going across my box right here, right? Oh, that's not too nice. I didn't draw that very well. Okay, do you see that? So I have this height here, which is 1, and I have the distance going across here, which I know is 2, because I was told it's 2 over here, and it's going to be the same length there too. Okay, so I know this is 2, and I know the whole thing is 7. And look at here. How am I going to find this length right here? How am I going to find that? Well, I need to know this little piece right there. How can I find that? Let's look at some other clues. Well, up here I have 1 going right here. So that means this is also 1. So that means this down here is 1. So there's a 1 here. So if this is 2 over here and this is 1, then in between these has to be 4. Okay, 2 plus 4 plus 1 is 7 all the way across. So then the volume of this middle shape is going to be 2 times 4 times 1, which is also 8. And my last piece is the tall skinny one here. And that is over here. That's this box on this side, this tower, okay? So I have 2 times 2 times 1. I want this tower right here. Okay, so I have 2 length, 2 height, 2 width. So 2 times 2 times 1, which is 4. So now I'm going to add all of these together to get the volume of the whole thing. Remember this line? Sorry, it's getting kind of thick in here. Let's go up here. So I've got 8 here, and 4 here. So 8 plus 8 plus 4 is 20. And what were they? They were just units. Let's call them centimeters. So this would be 20 centimeters cubed. Okay, here's number 4. It's called an oblique cylinder. The reason why it's oblique is that it leans to the right. Do you see that? It creates an obtuse angle here with the ground. Do you see that? So that makes it oblique. But we're still going to use our volume formula of the area of the base times the height. I just don't use the slanted height because that's longer. Okay, so my base area is going to be pi r squared, and I know my radius is 4. So that becomes 16 pi. Now, this is very important. it's the vertical distance. It's the perpendicular distance is the height. So remember, the height is always perpendicular to the base. And here's my base shape down here, okay? That sits on the ground. So I don't use the slant. Do not use that for volume, okay? So I'm going to have my volume equals 16 pi times 7, which is 112 pi, and that is 351.86. And what kind of units did we have there? Let's see. This was inches, so let's make that inches cubed. If it'll let me write it. There we go. All right. Okay. We're going to do one more, and then I'm going to give you some OIOs. There's a picture in your book of a wooden sculpture that lies on the ground, and it's all made of wood. So it's big like this. And there are 4 holes in it that look like this, and it's 3D. Okay, it comes down here like this. All right, and so what we have to do is we have to find the area of the whole thing minus the area of all of the little rectangles that are inside. Do you see that? These are all little rectangles. So let's find that. Let me see. It's 30 by 30 by 90. Okay. They also tell us that the dimensions of each beam are 30 by 30 by 90. So that means that I've got this down here is 30, going back that way. So first we're going to find the area of just the front. So we're going to take this whole thing, we're going to take the whole thing, and we're going to subtract the 4 small rectangles. Of the base. And then we're going to multiply by the height afterwards, okay? So the whole thing is going to be 510 times 90. And that is, let's see, 510 times 90 is 45,900. And now I'm going to take away 4 little rectangles. So do you see here that each one is 30, this length here is 30, and this length here is 90. So a small rectangle is 30 times 90, which is 2,700. And I've got 4 of them. 4 rectangles would be 2,700 times 4, which is 10,800. Okay, so now I'm going to do this. I'm going to write this in here in a different color so you can see it more easily. Here's my plan. The big rectangle minus the 4 rectangles of the base. So I've got 45,900 minus 10,800. And I get 35,100. That is centimeters squared. That's the base that looks like the front. It's the big thing minus all the boxes, okay? So it's just that area. Now I'm going to multiply that by 30 because I already took the pieces out. So I'm going to take this, the area of the base, times the volume is going, sorry, I'm going to move it over a little. The volume is going to be 35,100 times the height, which goes back this way, and that's 30. So I get a volume of 1,053,000 centimeters cubed. Okay? So with volume, sometimes with these, we take out what's in the middle. There's two ways to do that. Okay, I have some OIOs for you. I actually have 3. Let's do the first 2 together. So go ahead and pause the video, draw these problems, and we'll come back in just a moment and do them. Okay, let's go over this one. So I've got 2 parts basically here. I'm going to cut this here, right here. So I've got this block and this block. So my volume is going to be the big block plus the little block, right? Okay, so my volume of the big one is, I've got 3 here, and look at here, I've got 1 here, so I know I have 1 here, so that's good. And then going back, what have I got? I've got 1 here. See, this is a 1 down here, so that means 1 is here, 1 is here, 1 is here, and 1 is here. So that means that is 1 also. So, the big one is 3 times 1 times 1, which is 3. Okay. And then I have the other block, which is, if this whole length here is 3, we know this one is 1, right? Because this is 1 up here. Then this has to be 2, this little piece. So the whole thing is 3, but this little piece here is 2, from here to here. Do you see that? That is 2. And going up is 2, and going back is 1. So the more boxy looking one is going to be 2 times 2 times 1, and that is 4. So my volume is going to be 3 plus 4, which is 7. And my units are units. So I'm going to call it units cubed. Okay. So down here, number 2, I've got the volume is the base area times the height. What's my base? My base is a triangle. 1/2 base times height. So I have my right angle right there, so it's going to be 1/2 times 9 times 5, which is 22.5. Okay, and then we take that, the volume is going to be 22.5 times the height. The height of the whole thing is 8. So I'm going to multiply by 8, and I get 180, and this is feet. So this would be feet cubed. Okay, go ahead and draw this picture, and we'll go over it. You can pause the video again. Okay, let's go over this. So let's figure it out. So the volume, I'm going to have the big prism, triangular prism here, and I'm going to subtract this prism inside. Okay, it's a rectangular prism inside, so I'm going to take that out. So let's talk about finding this front picture. So I have the triangle, I redrew it down here, and this is 10. So, and I've got these little markings, so that means this is 10 and this is 10, okay? So I can draw my height, and I know it's going to cut this in half because by definition of an equilateral triangle, the height bisects the base. So then I'm going to use the Pythagorean theorem, height squared plus 5 squared equals 10 squared, to find my height. So I have height squared plus 25 equals 100. So that becomes 75, and I take the square root and I get 8.66. So my base area is going to be 1/2 base times height of the triangle. So I'm going to have 1/2, and the base is 10, times 8.66, and that is, I believe it's 43.3, but I'm just going to check because I want to be thorough. So I have 86.6 divided by 2, 43.3. Okay, but that's the whole triangle. That's the entire thing. Now I need to subtract this little square there. And I'm told that it is a square because it has the markings to show all the sides are the same. And I know it's 3 times 3. So my little square is going to be 9. So now I'm going to subtract the 9 from the 43.3. And that gives me 34.3. Okay, so that is the area of the base. I had to take out that little square in the middle. And now I'm going to multiply that by the height of the whole thing, which is 6. So the volume is going to be 34.4 times 6, which is 205.81. And these are centimeters, so this is centimeters cubed. Okay. So that is all. I will send you your homework, and I hope you have a great weekend. We'll be in touch about tutoring and getting tests back to you. Have a great day. Bye.